Okay, let's go ahead and get started. I don't know if everybody's like me, but I had a lot of coffee this morning, so I will probably be moving very quickly, blasting through a lot of this content, and hopefully we can learn something along the way. So this is Enhanced AutoPilot, automating the decision support process in complex warehouse operations. We kind of have three key things we're going to go through today. We're going to talk about some of the key challenges faced by distribution centers. We're going to talk about what the flow looks like in a distribution center. So everybody has these challenges, right? You go to any distribution center that is not completely soup to nuts automated, and you say, what's your biggest challenge? Well, labor and capacity. You're like, okay, easy. Let's break that one level further. Why are people running into the problems that they have? What does that flow look like when you're actually inside of an operation? And then the last piece is, what is a practical approach to introducing decision support to the warehousing process? It is a multi-step program, and we'll go through kind of what that looks like and the best ways to actually implement it. So who am I? My name is Keith Moore. I am the Chief Product Officer for a company called AutoScheduler AI. We have a booth actually on this side of the building. You guys are welcome to visit us at any point this afternoon. But before I was the Chief Product Officer for AutoScheduler, I actually have a mechanical engineering degree. I came up through an industry called the test and measurement industry. It's a really sexy industry, and worked for a company called National Instruments, where I started to work in control systems and vision-based solutions for all sorts of different clients. So I worked in oil and gas, I worked in semiconductor, I ended up working with a lot of the aerospace companies and like the control systems for self-landing rockets that you see today. So did a lot of really cool stuff, but I realized that we were providing so much data for our customers, when, sensorization and all this test equipment, that they weren't able to use it effectively. And so I moved into artificial intelligence. I was one of the first employees at a really small company in Austin, Texas. Grew that company. I did the whole Silicon Valley thing. If you guys have ever watched that TV show, it's really funny and a lot more real than it looks if you haven't been in that kind of environment. So I, did the whole turn a small company into a unicorn. That was a lot of fun. But then I was at that point, knew a little bit about sensorization, knew a little bit about machine learning and artificial intelligence, and really wanted to verticalize and really wanted to focus. So I and the team of kind of supply chain experts, so I have operators of 40 years, people that have been senior executives at major consumer goods companies that are helping us run AutoScheduler. I left, and we wanted to build a vertical solution focused on warehousing and the supply chain. And so that's, we're today going to talk a lot about warehousing, not a ton about AutoScheduler. But that's how I got here today, and that's why at least we'll be talking a little bit about decision support, the role of analytics, and really some steps you can take. So let's talk about the challenges faced in distribution centers today. I kind of highlighted it earlier. Almost everybody knows what they are. But the one that I'll highlight first and foremost is that people that are responsible for making decisions are extremely strained. Distribution centers are getting more complex. You walk a show floor like this, which is absolutely scary massive, and you see everything that's out there. You start to realize that all these different systems, there's somebody that has to manage everything and all the different pieces in a DC. And so most of my customers and most of the area I work are going to be consumer goods, so manufacturers, consumer good companies. I'll be kind of taking that angle. We're not going to talk too much about fulfillment centers, but a lot of what we do talk about will be relevant to them. And so a lot of these people are starting to have more and more software packages and robotic systems that are introduced that they need to handle. And so if we're looking just at the software, at a consumer goods company, a planner or somebody on the floor responsible for making decisions on how you want to run a 1.2 million square foot facility has to look at, well, what is a real-time transportation visibility provider providing me? When are trailers going to arrive? What trailers do I have on the yard? What needs to ship? What's in detention? What's my actual work queue look like? When are shipments supposed to go out? What's coming in? How do I balance this with the task force I have because somebody didn't show up to work and I haven't hired the 4 people that I need to backfill still? And then finally, a lot of these consumer goods companies and a lot of these manufacturers have production sites that they also need to account for. When's the line running? What's coming off of it? And how do I handle that? So we've created this environment that is extremely strained for the people in the warehouse. You might call them taskers. You might call them a line lead, a shift manager, a pilot. There's all sorts of different terms for them, but they are kind of the decision makers that are figuring out how to run the facility, they have a really hard time as we introduce more software and more hardware. And the primary technology that they're using is a warehouse management system. And I don't want to take away from any of the warehouse management system providers here. There's a lot of really cool new technology in warehouse management systems today. However, most people are not running state-of-the-art WMSs. They're running something a few generations ago. They have an upgrade plan, but it might get pushed, and they're not sure when it'll be. And so at most sites, that tool that is supposed to help planners, pilots, site leads actually make decisions is really good at a few things, but it's not really good at what it needs to be in order to help adapt to all these different software systems getting introduced. So warehouse management systems at most sites are really good at doing inventory management. They're really good at tracking what SKUs, what unit loads do I have in what locations, how old are they, do I have any rules around shipping them to different customers or export regulations, things like that. They're also really good at managing a work queue. And the reason why they operate as such a good execution system is they operate very well with things like scanners and all of the different hardware or devices that may actually be on a forklift. And they can perform that interaction. They can do the directed work. Some of them even have a decent way to prioritize work queues in buildings, things like interleaving. But what they don't do, and what warehouse management systems really struggle with, is that a distribution center is always capacity constrained. Like if you guys know anything about me at this point, I kind of look at everything through a mathematics lens. So what DCs are in their nature capacity constrained, in that you don't always have the inventory you need, you don't always have the space you need, you don't always have the labor you need. And when I say labor, I mean human or automated. So what does that capacity look like? And most warehouse management systems are not good at understanding what are the constraints that exist in my site and how can I actually intelligently optimize this work queue to get all of the work done that needs to get done. At the end of the day, I care about my fill rate, determine consumer goods is on time and full. They're also not great at actually releasing that work and intelligently making cuts. Is that me or elsewhere? No? Elsewhere, okay. And so if you actually think about inventory management processes, a lot of companies have, before it ever gets to the site, we're gonna make all the cuts we need to make. The reality is trailers still don't show up on time, inventory goes into quarantine, all sorts of weird things happen. And so you have to make cuts at the site, and a lot of warehouse management systems aren't intelligent enough to actually figure out, can I do that? How do I automatically do that? How do I keep a person or people on the floor and that tasker from making those decisions? They're not necessarily good at managing receiving and shipping simultaneously. These are generally two separate processes. And then they don't account for multiple buildings on a site. So if you're running a production site and you also have a main facility that you might ship to customers from, and then you have a second overflow facility, and they're all kind of housed under the same warehouse management system, actually balancing where should I ship from, when should I ship from there, when do I transfer inventory between all of these buildings is something that most warehouse management systems struggle with. So before we even get too far, I want to just call out, they're a great software, you have to have it if you're running a DC, but there's a lot of things they don't do, which is why taskers struggle with so many of the jobs that they have. And so why do they struggle? Why are taskers actually struggling outside of they may not have all the technology that they need? Let's also talk about what happens in a consumer goods site. Again, math, so I break everything down to a series of flows. And what we're going to look at is, what does the inventory flow look like at the ideal consumer goods site? So when I say consumer goods, just so we're all on the same page, we're mostly talking full truckload in, full truckload out, some LTL, but really the smallest unit you're going to be looking at is a case. You're not doing too much each pick, you're not doing pick, pack, and ship, kind of parcel operation. So the second something comes into a gate, there we are. It goes into the yard. They try to, they pass it in, and there might be some intelligent process that says go here, go there, but that inventory comes into the yard. From the yard, it's going to get brought into a door to get unloaded. From that door, most people do not unload straight to a rack. They unload to a staging location. So bring it into the door, unload it with a forklift, then you can use a reach truck or a different forklift possibly to go and put it away. So the put away process is different. Then put things away to a rack. So inbound process done. Now I have an order going out. I'm going to go retrieve something from that rack, bring it to a different staging area. From that staging area, I'm going to load it onto a trailer. That trailer is going to get put in the yard. If it's a drop trailer, it could be a live, could be a drop, and that's going to get checked out. But most sites don't actually run this simply. Most sites are not pallet in, pallet out. Most pallet in, pallet out sites most pallet in, pallet out sites are very simple and generally fairly small. So today, there's a lot more customization in orders even in consumer goods. So you might have processes like case pick and layer pick that need to be considered. So there's now workflows of how do I branch people off to spend time on different tasks instead of just pulling things from rack to staging. There's never a linear flow in a distribution center. And beyond case pick and layer pick, you may want to get a little bit more intelligent about how you actually use your space. So you might introduce things like cross-docking. So, I can either pull things from a rack to a staging area for an outbound shipment. I can pick some of those orders. When do I use layer pick? When do I use case pick? Generally, there's some triggers for doing that. And in some cases, I may not want to put it away at all. I may want to unload an inbound and bring it straight to an outbound trailer or straight to an outbound staging area and reduce all of those processes in the middle. Less touches into DC, saves more money, increases capacity. So you end up with this workflow that's not really that simple, even at a site that's not dealing with that many SKUs, and it may be doing mostly pallet in, pallet out. There's a lot of these different operations. And in some cases, you make it even more complex. You might have a flow zone or a packaging area for when case pick is done, you have to make sure you can get it to the right wrapping station. Or you might have a near door staging area that you've introduced because you're trying to flow the right product through and you're always looking at what's the right product to put there and how do I drop things off there so I can pre-stage them, so I can stage them, so I can load them. This is obviously a fairly simple map of a distribution center, but it gets pretty complex. And then you can add another layer of depth to it, which is not everybody can do everything. I can't just map inventory through this magic flow and say, well, I know when it comes in, I know when it's going out, and everything's just going to magically happen. There are different actors that can do different things. And I use the term actor because that's kind of a constraint optimization term. But in a primarily manual, so a lot of human labor distribution center, you have associates in the yard that can do certain things, and they're actually moving trailers around. You have a finite number of those. You have so many people driving forklifts, so many people driving clamp trucks, reach trucks, so many people on case pick and layer pick, and they're kind of tasked to certain areas, and there's a changeover cost with moving where people are because you have to have the equipment, it needs to be in the right state, and you need to have people with the right permissions to actually use that equipment. And so there's a different level of depth when you think about the problem, not just from a flow perspective, but also from the people that can actually do different tasks. And then we're introducing automation, right? Why are we here? What do we see on the floor everywhere is there are a lot of really cool automated systems that can help improve capacity at sites. Absolutely, you should do it. But most people don't go from no automation to full automation overnight. You introduce an ASRS, you introduce automated layer pick, automated case pick. There's generally one thing you have to consider, and while you're doing that, you're increasing your capacity for that function, but you're not necessarily thinking about the full flow of how does inventory move around the building. Because now there's new actors that can perform different tasks. There's people that are responsible for picking up and dropping off or doing different things at the fringe of what that mechanical system's capable of doing. And so what you end up with is this massive series of flows that gets more and more complex the more automation you introduce. And more complex as you start to use things like AGVs, which again are a fantastic technology, but AGVs and human forklift drivers don't drive the same speed. And so what are they doing? How do you factor in when you're releasing work where? And speaking of releasing work, you kind of take this whole thing, and these planners aren't just saying, well, let's map through these series of flows for this order. They have to do more than that. They actually have to figure out, there's three key things that planners and taskers are doing at sites. They have to allocate, which is what inventory am I assigning to what order? So most warehouse management systems have a pretty easy process for doing this, but people generally do that today. So they allocate and they assign the inventory to the order. The next thing they do is they release that work, and they actually push that work into the work queue, meaning somebody will now be able to pick up that work. And then over time, whether through heuristics or through manual intervention, these planners are responsible for managing the work queue. Because people generally pull off the top, work queue is like a Pez dispenser. Priority, proximity, permissions. Can I do something? Let's get the thing at the top of the work queue. What are my rules around breaking zone? When do I want to do it? And so people are responsible for taking this massive complex series of flows, layering inventory management on top of it, and then simultaneously balancing that for every single task that needs to occur. And the problem is, for one shipment, you can have 50 plus tasks that actually need to be created. I had a long example that walked through one shipment with 50 plus tasks, then I realized we didn't have time for it. So if anybody wants to see that, I can go through it later on. But to provide an example, I might have an outbound trailer, so an appointment time for 12:30 p.m. And if I back schedule, and this is a fairly simple back schedule, I can look and say, well, in order to have that out the door at 12:30 p.m., I need to start loading at 12 o'clock because it's going to take me 30 minutes to load all those pallets onto the trailer. But then I need to make sure that it's in staging by 12 o'clock, which means I need to pick it. That might be full pallet pick, that might be case pick, that might be layer pick. There's all these different processes I could look at to do it. Turns out it's a heavy case pick order. It's going to take me 2.5 hours to actually case pick that whole order. So I need to start my case pick at 9 o'clock so that the whole order is picked by 11:30 so it can be staged by 12 so that it can be shipped by 12:30. But I don't even have the inventory in pickable locations to case pick. There's some inventory that needs to be replenished. And so I need to replenish that inventory by 9 o'clock. But turns out I don't actually have it in the building. And so what I may end up doing for a single shipment or a single outbound order at 12:30 is I'm pulling in a trailer into the door and it needs to be in there by 7 o'clock so I can unload that trailer for 8 o'clock, replenish for 9 o'clock, pick for 11:30, stage for 12, load for 12:30. That's one shipment, right? Most sites don't have one shipment a day. There are sites that are doing hundreds of shipments a day. And so as a planner or a tasker, you're working through this whole flow and all these different layers on top of it around inventory management and task management and when do you release work. And you also have to figure out like, okay, when am I going to be short and how do I deal with that customer? And how do I deal with all the fires I'm actually facing in this building? And my management's asking me to cut 5 to 10% of costs for the building for the year. And so they want me to minimize travel distance and optimize dock door assignment and figure out how to minimize detention and maximize labor capacity. And they have in mathematics, what we call is a combinatorial optimization problem that they have to do in their head every 30 seconds to try to make sure that the site is running as it should be at maximum capacity, minimal cost. And it's a hard problem. So what do we do about it? So let's actually solve that problem. What does decision support look like for this process optimization? Again, we're going to talk purely for distribution centers. I can't speak to a lot of the other things, but if there are questions on them, if we want to talk transportation or planning, we absolutely can. So for DCs, this is something Gartner's already recognized as a huge initiative in supply chain. So surveys go out, and what's your top funded initiative? Well, digital transformation. You're like, okay, obviously, right? Everybody gets that needs to be the top thing. But the next highest scoring item that ranked in people's top 3 was enhancing and accelerating decision support making. The world at this point knows this is a problem. Everybody's starting to recognize it. I'm just highlighting it here. And so to actually do that, we basically need to take this guy and all the software packages that he's dealing with and all the decisions he has to make, and we have to replicate a lot of his activities while simultaneously being a little bit more omniscient because people can't actually manage all of the data that comes in. I was walking the floor this morning and was thinking, oh my God, there are so many vendors here. Like there's no way I could possibly actually understand what everybody does on the floor just in the 3.5, 4 days of the show. And it's the exact same way with this person who has to deal with it every single minute. So we want to be able to take what this person does and really help them with a decision support system. So that is the goal. The decision support system and where they should be used in distribution centers is a way to manage all this information and help people understand the best way to run a facility given the different objectives that you have at your site. So what this needs to look like, and I want to really call this out, is there are a lot of screens. And just about everybody says when it comes to supply chain software, I don't want just another screen, right? But there's a lot of screens that these people are using today and people in this organization are using today. And so what you want to do is you want to try to shrink that footprint down to where the decision support system can be a system that people are interacting with, and it can actually do a lot of the tasks that they might have historically done in a warehouse management system. So one thing, I did some work in cybersecurity for a while, and one thing that security operations centers got right is they've had this concept of one pane of glass. There should be one pane of glass that people are looking at to understand the total state of the operation and decisions that need to be made. That's what decision support systems should be. They should be one pane of glass that tells you everything you need to know about running a distribution center. So they should give you plans, they should tell you how you're mapping to capacity, they should give you warnings on when you're going to run into issues well ahead of time. And that gets into kind of some of the mathematics and the operational twin side of things. But what this looks like at a really high level is you have your warehouse management system. As I mentioned earlier, you want to keep your warehouse management system. It is a really good technology that has a lot of value inside of that building. It's going to send data to your decision support system. Your decision support system will happily sit there, perform a bunch of optimization, so this constrained optimization that needs to happen, and it's going to build this awesome plan. And so planners and these taskers can then look at this plan and say, huh, this is interesting. What do I want to do about it? And they can take the pieces that they like, and they can actually go and execute that work in their warehouse management system or the warehouse, WCS, WES, depending on how they're actually implementing the execution of work. Primarily, we're talking allocation, work queue management. So this process works really well to say, I want to use a decision support system. Where do I start? It's like, all right, bring it in, get data from the warehouse management system. I had a question earlier about what sort of data are we talking. So there are really 5 things that you need effectively to do this. You need locations. You need to know where everything is. You need shipments. You need receipts. You need inventory. So what inventory at what age do I have in what location? And you need item master. What is the cube of every single case? How many are on a pallet? How many to a layer? What does the weight of that look like? Those are kind of the minimum things you need to run a good decision support system in a distribution center. Now there's a lot more data that makes it better, like if you have a labor management system, even better. If you have a yard management system, better data we can use. If there's integration to production, like an ERP integration, you want that data as well. But at the floor, you need a warehouse management system. And so all of this works, and it works well, except for we talked about having a single pane of glass. And what we found, so at AutoScheduler, I mean, you guys probably guessed this, but we build decision support systems and really warehouse optimization systems. What we found when we started to implement this approach, thinking we're going to pilot it and we're going to let people see what it does and actually make those changes themselves, is that every time a planner needs to actually go and look at one screen and then figure out how to implement it in another screen, it introduces more clicks, right? We already talked about how precious their time is and how many things they have to deal with, and not even including a lot of the fires that actually come up in these buildings. And so every time we introduce a process that might make their distribution center more optimized, but does not optimize the planner's time, it's a challenge. And so most deployments of these decision support systems, the customer always wants to start here and say, we'll look at it and then we'll figure out what to do. You're like, all right, great. We get about a week in, and then they're like, nope, this is taking too long. Can we automate some of it? Can we take, basically, in this decision support system, all the recommendations that they have, and can you give us, I call it the easy button, right? I invented that term, thank you. And so give them an easy button. If they can see a plan, even at like the carrier move level, and understand what are the different steps and what is the optimized workflow to get this done, and understanding it accounts for all the other shipments and all the other receipts and all the other considerations to maximize your objective, can you just give us a button that says like, yeah, do this part, yeah, do this part, yeah, do this part, yeah, do this part, and then direct inject that work back into the warehouse management system. So instead of a person having to look at one screen and then go into another screen, do a bunch of typing and clicking, just click a button. And all of a sudden, all that work they were going to do, all those clicks they were going to do for releasing work, allocating, they don't have to do them anymore. They get to do it in one click. And eventually, they get really comfortable with this. I look at some of the sites that are yet to transition to this third part, and you say, okay, well, where are we on the decision support side? How often are they using the easy button? And every morning you log in, and the easy button is just checked for every single recommendation. And it's constantly, every day, just if something new comes in, check it. And at that point, you're ready for the third stage, which is how do you actually put a site on autopilot? So autopilot is when you have the decision support system making all of the easy decisions that can be made while accounting for all of the data that cannot necessarily be accounted for by people, and maximizing the objective in a mathematical sense. And so you have this decision support system pulling in data, directly pushing recommendations back to the warehouse management system, always letting planners and taskers understand what the workflow is, always highlighting and creating alarms if there's going to be issues, but not necessarily requiring them to approve every single thing. They can just go in and change things around, disapprove of things as is needed, instead of having to be on call to actually make sure they're there to release that work into the WMS. So that's kind of where we're going. And so what this gives you in a decision support sense is, before just kind of looking at the problems that we talked about, there were 50 tasks per shipment, manually approved. They were releasing the work. They were trying to figure out what were priorities, what needs to happen first, what are the sequences that need to be considered. People are spending hours a day. A lot of sites, most sites, have more than one tasker or shift lead on at a time. And it becomes a huge expense, particularly because those people are so hard to find and so hard to train. And there's a lot of functions that they're doing that are fairly tedious work. So that's what happens before you have a decision support system. After you introduce this concept of decision support to the site, even if it's not for everything, you end up with one-click allocation, assignment, and execution. You're taking a huge amount of time that is spent by planners and condensing it all the way down to minutes, if not a little bit more than that. And the next thing that you can do is you can do this automated error handling, and I'll talk a little bit more about what that looks like in a second. But if you guys have been in facilities, you know nothing ever goes to plan, ever. And so you need the ability to, if I say I want to do something, but then certain conditions change, I should probably revise my plan. And so because of this and what decision support systems do, it's not like you're building a plan in the morning and then you're just using it for the rest of the day. You are building that same plan over and over and over and over as data changes, as conditions change, and constantly realigning with the WMS to make sure that the decisions that are being made are always optimized to the where you are now and the where you want to go in the future over the next 24 to 36 hours. Most of these execution tasks, you're not looking much further than that because you often don't have much more data than that. So as a quick example just of one of the sites we went to recently where we did this, this is actually the site that we stayed in the pilot mode where they got to read and then they go change things in the WMS. We stayed there for about a week, but their big KPIs, we're doing all of this work for them, and their big KPI was cross-dock. We want to cross-dock more. Take inventories from inbounds, move it to outbounds, but we have to consider all these things around what product lot is it, when it can be shipped to customers based on code dates. And so we took this site, and overnight, it went from 2% cross-dock to over 10% cross-dock. So the second thing that it did is integrated with the WMS and would dynamically prioritize the work queue and dynamically constantly prioritize the work queue to make sure that all the tasks that are needed to facilitate cross-docking are actually happening appropriately. So we bring in the right trailers, or we bring them to the right door, because you don't want to cross-dock 100 doors across, right? Are we bringing them to the right door? Who is doing what? Are we making sure we're getting things unloaded and loaded at the right times? What are the start times for those tasks? What are the end times? As soon as somebody scans a pallet, the WMS is auto-directing them. You're moving this from staging bay 47 to staging bay 48, right? And then we're actually simultaneously doing the error handling. Well, we plan to cross-dock this inventory. However, the inbound trailer didn't arrive on time, and the outbound appointment is in 4 hours. What do? Do we keep the inventory reserved for cross-dock, or do we cancel, reallocate, figure out where we can get this from the building and make sure that we can do that in time to get the outbound shipment out? All of that error handling is handled as a part of this decision support process, so that it is a no-frills, point-and-click, easy button solution for introducing cross-dock. And so planners at the site were spending hours per day actually getting this in. As a little bit of an older warehouse management system, so they didn't make it easy for them because they had to find opportunities and then actually take advantage of them. That process now takes about 2 minutes per day. So huge amount of planner savings, huge amount of productivity gain because you're saving at I think it's 850,000 square foot facility. You're saving a huge amount of travel, put away in retrieval, and a lot of labor hours, and takes maybe a minute or two a day of your time. So that's what decision support can do in a really narrow, verticalized sense. Beyond when you get to the later stages, when you get into kind of what I was talking about earlier, which is you're allocating, you're releasing work, you're dynamically reprioritizing the work queue, you're doing things like mission assignment, and trying to minimize the actual travel distance everybody on the floor is moving at any point in time and changing the work queue to adapt to that. That's when you start to talk about your 10 to 20% capacity increases at a site, or capacity reductions depending on how you want to look at it, right? I always view it as you will get more capacity from the labor that you have. But that's kind of the power of what these systems provide. And why I wanted to highlight them is, one, there's not really a huge industry for decision support and warehousing. And two, this is not something that you need to go out and figure out what to rip and replace to get it. Decision support systems are purely complementary, and there's quite a few vendors in the space that have offerings, depending on where you guys are, that can complement the software you already have and just allow your teams, particularly in distribution centers, to actually gain the advantage of a lot of the data that you're not necessarily sharing with them, or they don't have the time to consider and understand when they're making day-to-day decisions. So, in summary, current technologies for optimizing execution aren't sufficient in warehousing. Enhancing human decision-making is something we all know about, but it's going to get more challenging as more automation and more software is introduced. And the best way to actually resolve this is decision support systems that let you improve site capacity as automation grows. So with that, my name's Keith Moore. We're in booth C5471.